Our major science problem focuses on turbulent reacting flows as it applies to mostly propulsion and power systems. That's one of the classical grand challenge problems from the perspective of simulation and modeling. When I say propulsion, that could be diesel engines in trucks, internal combustion engines in your car, gas turbine on an airplane, any kind of rocket. In all of these engines, there's always turbulent reacting flow processes, which means we inject fuel, there's oxidizer. Those two things have to mix. And not only do they have to mix, then we have to burn them. And how they mix really controls how the combustion takes place. And we would like to be able to simulate these processes predictably. There's phenomena that we either want to enhance or we want to make sure don't happen. We want to get maximum performance with minimal or zero emissions. An example of things we don't want to happen are combustion instabilities. In a liquid rocket, for example, combustion instabilities can actually destroy the engine in milliseconds. A key challenge with this type of flow is not only is it multi-scale, which is due to the turbulence, so there's a wide range of time and length scales that we have to deal with, but we also call it multi-physics. So we're not just talking about fluid dynamics or thermodynamics or heat transfer, but we have all those things going on at once. We need the power built into Summit to make advances. Just the sheer magnitude of the interaction and the degrees of freedom makes it extremely difficult to use these models reliably and predictably over different ranges of engine operating conditions. But if we can improve the predictive capability of the simulations, we can use those to understand how to make engineering models that industry can run very quickly and reliably. So the more computational power we have access to, the more things we can do to improve the resolution of important features of the flow. One of the things that Summit now brings is the size of the machine, enabling calculations that we would never be able to do on most machines in the world. The potential power encapsulated in these nodes is just remarkable. The newest GPUs have much better bandwidth, much faster. So we've had the opportunity to run on Summit, and if I look at the speed with which the code was running on Titan, and now the speed on Summit using the GPUs, it's on the order of 25 times faster. As we move towards more predictive models, you're going to see innovative design. We're going to get improved fuel economy, reduced emissions, high performance. Being able to get on Summit changes our whole workflow and the way we approach our research.